Alright, this is lesson 7.3. We're going to call it A. I'm assuming it looks like kind of a long chapter, so we're going to be making a couple videos here. 7.3A, Intermediate Algebra, Compound Inequalities, and Interval Notation. And we're just going to jump right into example 1. And it says solve 3, let me get my pen working, 3x plus 3 is less than 2x minus 1. Okay, so when we solve inequalities, we're going to solve them as if this inequality sign is an equal sign. So we're just going to do everything the same way. Subtract 3, subtract 3. And just ignore that inequality sign right now. Okay, we're going to bring this over by subtracting. X is less than negative 4, and we're done. Alright, now, one of the things that you're going to learn here is there are going to be several different ways to write x is less than negative 4. One of the ways that you're going to write this is using what is called inequality notation. That's what we have right there. And I would suggest you putting these down in your notes because I may ask you to write your answer in a certain notation, and if you don't remember which one is which, you're not going to know how I want it written, and then it's going to be wrong. So that's inequality notation. If you can read my writing. Alright, there's another notation called graphing that you've already used, and if you want to graph that, you have a number line, and if you put 0 here, obviously, well, let's move the 0 since it says negative 4, and let's say that's negative 4. And if we're going to show x is less than negative 4, it means x cannot be negative 4, right? So remember, you put an open circle when you're showing where it's starting but doesn't include, and then it says it's going more negative. It's going more in the left direction. Okay? So that's another way of writing it. That's a graph using parentheses, or I'm sorry, open or closed circles. In this particular case, because it cannot be negative 4, it's an open circle. Now let's look. We drew an arrow going to the left. How far does that go? It goes forever. And if you remember, forever in math is labeled with a symbol that looks like that, which means infinity. It goes into infinity. Now, it not only goes into infinity, but it's going left, so it's going into negative infinity. Whereas over here, that is positive infinity. Remember, there are two different types of infinity. One's negative and one's positive. You can't just say infinity. You have to write which direction it goes, left or right, positive or negative infinity. So that is graphing using open or closed circles. Now if we want to graph it another way, which is the way you're going to end up doing it if you go into a higher level math, everything here looks the same, only instead of an open or closed circle, we're going to use parentheses or brackets. Okay, a parenthesis is round, and that means that it does not include the negative 4. If we were to make a bracket like this, that means it does include the negative 4. So that kind of notation is called just graphing using parentheses or brackets. And that's how we're going to be doing most of our graphing from now on. And again, the only difference between this type of graphing and this is the round one means it doesn't include the negative 4, just like the open circle does not. The squared off, if that were like that, means it does include the negative 4. Alright, and another way of writing this notation is called interval notation, and the way it works is this is our parenthesis bracket, if you look at that as a source for your interval notation, what you do is this side, the right hand side, is going to be like this, or if it was a bracket meaning that it includes -4, it would be written like that, but in this case it's round, saying it does not include the number to the right. And then we look and see what it's doing this way. This way it's going into infinity, and it's a negative infinity. Notice how I have a closed or a rounded parenthesis here. That means it does not include negative infinity, because you could never get to infinity. So it can never include infinity. So whenever you have the symbol infinity, it is going to be a curve right there. And if this is confusing, it will get easier as you see me do different things. Alright, so there's one final method of writing this, and this is called set notation. And we will practice all of these so that you get familiar with how to write these. And set notation, again, we're still looking at this one up here, says we make a set, we write an X, we write a line, we write an X, and we write the answer. And that's it. Okay? So the answer goes here, and we write parentheses, X, line, and then the answer. This says the set of all X such that X is less than -4. So if you read that, that's what it says. The set of X such that, that line means such that, X is less than -4. Meaning, all the numbers that are possible are going to follow the rule of X of being less than -4. Okay, so those are all your notations. If you look on the middle of page 409, it gives you examples of all the different notations there. And we will keep practicing these as we go. So let's look at example 2. And we have -2y minus 3 is less than or equal to 7. So we're going to solve that again, just like it's an equal sign. You've done this before. Add 3 to both sides. Now we're going to divide by -2. Remember, when you divide by a negative, what happens? The symbol changes direction. And we get an answer like that. Alright, so that is the answer in inequality notation. The answer in set notation will look like this. Y such that y is greater than or equal to -5. So that's called set builder notation, or just set notation. If I want to use a graph, and let's just put -5 there, and we're saying that y is bigger than or equal to. So because it's bigger than or equal to, we're going to make our squared off bracket, meaning it includes -5, and it's going into infinity. Now if we want to write this in interval notation, it looks like this. Okay? Looks like that. And we got that again, is the left hand side is a -5 with a square. The right hand side, there isn't a right hand side, so it's infinity, and infinity is always rounded, and it's a positive infinity. Now you can just write infinity, or you can write a positive infinity. It doesn't really matter. When you get into calculus and stuff, you'll have to write the positive on there because it means different things. So anyway, just something to consider. You can put just a regular infinity, or not an infinity at all, or not a positive at all, just leave it. Alright, so that gets us to the next section, which is compound inequalities. Alright, so we're up to about 10 minutes. So I'm going to end this video, and we'll start 7.3, B as in boy.